No heater, no air conditioning. Negative 20 degrees outside. Inside, 70 degrees. Warm floors, quiet rooms, nothing running. That shouldn't exist. But it does. It's a real building in a real city, running that way for over 30 years. The technology exists right now. It costs nearly the same as a regular home, and almost no one is talking about it. Here's what's going on, and why it makes the house you're living in look like a very expensive mistake. Start with what's already happening to your wallet, because these numbers are uglier than most people realize. 50%. Half of every dollar you spend on energy goes to one single thing: keeping the air inside your home at a temperature your body can handle. Not your refrigerator, not every device you own running simultaneously, just the air. That's $1,000 to $3,000 a year depending on where you live, fed into a system that breaks, makes noise, pollutes, and shuts down completely the moment the power grid blinks out. Every dollar of it spent fighting the outdoor climate. Every hour, every day, every year you own the place. Winter shows up and you burn fuel to fight it. Summer arrives and you run a compressor to fight that. The machines never stop. The bills never stop. And almost nobody ever stops to ask the obvious: is fighting the only option? It isn't. And the proof has been sitting in Germany since 1991. That year, researchers in Darmstadt built the first certified passive house. The idea sounds almost too simple. Design a building so precisely around physics, sunlight, and local climate that it holds comfortable temperatures completely on its own. No furnace, no air conditioning unit, no mechanical system grinding away behind the walls. It worked. For 15 straight years, that building ran on nothing but body heat and sunlight. 15 years? Summer temperatures inside held below 77 degrees, while the city baked outside. Winter comfort stayed steady while the heating bill sat near zero. And here's the part worth sitting with. They didn't invent a single new material, no secret technology, no breakthrough resource. They just stopped fighting nature and let physics do what physics has always been capable of doing. The house finally got out of its own way. So how does it actually work? And this part is simpler than you'd expect. South-facing windows, triple glazed, pull winter sunlight directly into the living space during the short, cold days when warmth is hardest to hold on to. The sun does what the furnace used to do. No fuel, no cost, just glass pointed in the right direction at the right time of year. The walls run thick, 12 to 20 inches of dense insulation, sealed so tightly that almost no air passes through. Think about a thermos. Hot coffee stays hot for hours with no heat source because nothing can escape. These walls do that for the entire house. Whatever warmth gets inside stays inside. Whatever cold is pressing hard against the outside stays outside. And here's something that catches most people off guard. The floor does work too. Concrete or stone absorbs solar heat during the day and slowly releases it back into the room through the night. No electrical element, no wiring, no system attached to it. Just thermal mass behaving the way it always has, completely silently while the house sleeps. Ventilation is where it gets quietly brilliant. Sealing a house that tight creates an air quality problem. So passive homes solve it with buried pipes that draw fresh air in from outside. That air travels through the earth first, and the stable ground temperature warms it before it ever enters the living space. When warm, stale air exits, a recovery unit captures around 90% of its heat and hands it straight to the incoming cold air. Fresh air in, heat stays in, nothing wasted. In summer, the geometry takes over. Overhangs above the windows, sized precisely for the sun's summer angle, shade the glass during peak heat while still letting lower winter light through. Night vents open and flush the day's accumulated heat out before tomorrow can build on top of it. No compressor, no power draw. Just the shape of the building doing work the machines were never needed to do. Now, the numbers. And this is where it stops feeling like engineering and starts feeling like something's been kept from you. 2 to 4 people. That's the entire heating system. The natural warmth generated by a small family cooking dinner, sitting together, moving through a normal evening. Enough to heat the whole house through a full winter. Not reduce the load, not cut the bill, replace the furnace entirely. Outside temperature crashes to negative 20 degrees Fahrenheit. Nothing running, no active heat source anywhere in the building. The interior holds within 50 degrees of outside and sitting somewhere in the 30s at its lowest, for days on end, completely unassisted. Then flip it. A desert summer climbs to 110 degrees outside, dry heat pressing against every wall. Inside, 70 degrees, no air conditioning, no power consumed. A building that handled it before the foundation was ever poured. And the energy comparison is where this crosses from impressive into something that's genuinely hard to justify. A standard home burns roughly 150 kilowatt hours per square meter every year just managing temperature. A certified passive house uses fewer than 10. That's not a 20% improvement. That's not even close to the same category. That's 90 to 95% less energy year after year across the entire lifespan of the building. Run that number across 50 years and it stops looking like savings. It looks like two completely different financial lives. Real buildings, real extremes. And the results keep showing up wherever someone actually tries this. Earthships in New Mexico have been proving it since the 1970s. Walls built from stacked, earth-packed tires. Zero utility connection, zero grid. Sitting in a desert that freezes in winter and regularly hits 110 degrees in summer. Interior temperature holds in the low 70s, year-round. Decade after decade, completely off-grid. Off-grid cabins across Canada run these same principles through winters that push conventional heating to its absolute breaking point. European apartment buildings retrofitted with passive design are watching residents bank over $2,000 a year in savings. Not from better appliances, not from rooftop solar, but from treating the building itself as the system, rather than the thing machines are bolted onto to compensate for. Here's the contrast that becomes hard to let go of once it fully lands. A conventional home never rests. Systems cycling, temperature swinging up and down, background hums so constant you stop noticing it, bills arriving like clockwork, and real fragility, because when the grid fails on the coldest night of the year, a standard home becomes dangerous within hours. A passive house on that same night holds its temperature for days, silent, stable, completely unaffected by the outage outside. Same storm, two completely different outcomes. The upfront cost runs 5 to 15% above a standard build, and that gap disappears within 5 to 10 years through energy savings alone. After that crossover, the house generates money every month by simply not needing fuel. Stretch that across a 60-year lifespan, and the gap between a passive house and a conventional one stops looking like a building preference and starts looking like a question someone should have been asking a long time ago. So why isn't this standard? Why is the industry still producing the same thermally leaking boxes it was building in 1975? Passive design demands precision before the first wall goes up. Orientation has to be right. Overhang depth gets calculated, not eyeballed. The building envelope needs to be close to airtight. That level of upfront accuracy takes time and expertise, and the industry isn't always rewarded for either. But there's a quieter reason that almost never gets said out loud. A house that doesn't need a furnace doesn't generate furnace revenue. A house without air conditioning doesn't generate service contracts, maintenance visits, or 11 p.m. emergency callouts in February. The entire revenue cycle built around mechanical climate control, the equipment, the installations, the annual checkups, the parts, the labor, has absolutely nothing to sell into a building designed to make all of it unnecessary. Industries with nothing to sell into a market don't champion that market. They stay quiet, keep building the familiar way, and let the status quo do the work for them. The future of housing was never going to be a smarter thermostat or a more efficient compressor. It was always going to be buildings designed from the beginning, so those systems simply aren't part of the equation. In a world where energy costs keep rising, summers keep breaking records, and the grid keeps proving it cannot handle what's being asked of it, the answer was already built, already tested, already proven in a German city 34 years ago. It's been sitting there ever since, holding temperature, waiting. Nature already solved this completely. The only thing left is building like we actually believe it.